All right, we have problem 8 of our calculator portion of the SAT math section. So again, we're reading our question first, just like the last question. We're using the same table, but let's read the question first and find what's asking us, because you could read this for like 10-15 minutes and you could find that you understand all this information. You can name blindfolded how high Mount Craig is. You can name how high the Clingman's Dome is without even looking at the table. But is that going to help us for our problem? Maybe, maybe not. Oh, look, it's not. Because for the given Appalachian mountain peaks, what height of the highest peak is approximately percent of the height of the lowest mountain peak? So, will that help us? Maybe, maybe not. We don't really know yet. So first of all, which height is the highest peak? We're going to call that H for the highest. So that's going to be the tallest or biggest number, right? So what number is biggest here? We see all of them have to start with 6, 6. So whichever, oh, and we can see that they're ordered by highest to smallest. Look how nice that is for us. So we have Mount Mitchell, and we don't even have to name the name because we just need the number. It's talking about just the height of the peak itself, and we don't need the name. So we can just write down H equals 6684, which is 6,684, right? So that's the highest one. Our lowest one equals 6,611. All right. So we want to know what percent greater the highest peak is of the lowest peak. Again, for the given Appalachian mountain peak, so not the Rocky Mountain ones. Remember, we're looking at the Appalachian ones. The height of the highest peak is what percent greater than the height of the lowest peak. All right, right off the bat, what does that mean? What percent greater? It means specifically the single digit that's below 100% bigger it is, right? So we can use our calculators. And right off the bat, using that information, we know it can't be D, right? Because something that's 101% greater, that means it's more than double. 100% greater than something else means it's double the size. Like, for example, if I have a pencil, this is my pencil that I use for everything. Ta-da. If I have a pencil that's 100% greater in size, that means that pencil's like twice the length or twice the width or something, right? So using that information, we know that it's not double just looking at it, right? It's going to be a very small percentage. So it's either maybe 1.1%, maybe it's 9.9%, but let's find it out. So we have 6,684. We can just divide that by 6,611. And then the most important step, because we got that, since this is a decimal, we can convert it to a percentage. 1.011 equals, we can move the decimal place over once, twice, because it's times 100, to get back to a percent from a decimal. That's going to be 101.1. So we can see that's that answer, and that's a percent. But you have to subtract 100 at the very end, because we know that this is 100% of itself, right? So subtract 100, we get 1.1%. The other thing you could do is just subtract 1 from this one and get 0.01, and then just move it over and get 1.1%. 0.011 and get 1.1%. Same thing, our answer is A, 1%. And that makes sense, right? Anytime we have an answer, it's good practice to look back and see, does that make sense? Is this highest one 1% greater? Yeah. It looks like it's about 70 greater. It's the same number of thousands, 6,000s, same number of hundreds, 600s. It's barely bigger. It makes sense that it's like 1% bigger, right? So our answer makes sense. Our answer is A.